All right, we're going to do section 1.1, page 10, number 44, modeling distance traveled. The problem reads, a car starts from point P at t equals 0 and travels at 45 mph. Part A asks us to write an expression for d of t for the distance the car travels from P. There are several ways that we can look at this. And I think if we use some common sense and rely on some previous experience, we'll be able to solve this problem. I also think whenever you're approaching a math problem, and especially a problem that might have some physics involved, this should kind of sound familiar from freshman physics, that making a table can be very useful. So if I'm going to make a table, the question is, what am I going to put in my table? Well, I'm supposed to be finding an expression for d of t, so I should probably have d of t as one of the columns in my table. And then I know that d of t is a function of t. That's going to be my independent variable, so that too belongs in my table. And we have to remember that d of t is the distance the car travels from P. And because of the background that I have in physics, and that many of you have because you're taking AP Physics at the same time, I'm going to introduce a different variable here, which is going to be x of t, which is going to be the position of the car at any time. And we'll be able to then measure d of t as distances from P. So, what's our first entry in this table going to be? If we look at the problem, we can see that we have some information that when t is equal to 0, the position of the object is P. We're asked to find d of t, which is the distance the car travels from P. So at t equals 0, the car is at P, and how far have we traveled from P? That's right, it's going to be 0. So I've got my first entry in the table, but 1 point isn't going to help me develop an expression. I'm going to need more than 1 point. So what should my next time step be, my time increment? Let's look up here at the problem again, and the only piece of information that we have about how the car travels or moves is this 45 mph. What does mph stand for? Well, you see it in your car every day, and it's miles per hour, which we can write as a rate, miles per hour. So we know that every 1 hour, the car is going to move 45 miles. 1 hour might be a good next interval. And now we need to know where the car is going to be. Common sense is going to tell us that the car has moved 45 miles. But if you have a situation where you can't trust your common sense, we could actually use dimensional analysis. We have 45 miles per hour is our information about the speed of the car. And we know that we are going to be traveling, or our car is going to be traveling for 1 hour. So the hours are going to cancel, and we get that the car has traveled 45 miles, which is what our intuition told us. So the position of the object at 1 hour is going to be P plus 45 miles. And then the question is, what is d of t going to be? How far has the car traveled from P? And the answer is 45 miles. Now we have 2 data points. Again, that's not really enough to help us find an expression. 2 data points could mean a curve, it could mean a straight line, we don't really know. To really figure out what this expression is going to look like, we're going to need a 3rd data point. It probably makes sense to go to 2 hours using hour intervals. Again, your intuition probably tells you that the car has moved another 45 miles. But just to practice, in case you're in a situation where your intuition isn't helping you, we know the car moves 45 miles every hour, but now I'm going to multiply this by 2 hours. Again, my hours cancel, and now I'm going to get 90 miles. So my new position is going to be P plus 90 miles. And my d of t, which is the distance I've traveled from P, is going to be 90 miles. All right, so we have 3 data points here. What do you think the equation for d of t is going to look like? Do you think it's going to be a linear function, a line? Why or why not? Well, I'm thinking that it's going to be a line because as I take these even increments for t, increasing by an hour, I also find that I have even increments for my increase in d of t. Well, let's see if this is going to work. We need to find our expression for d of t. We think it's going to be a line. You need to choose your favorite way of finding a line. My favorite way is the point-intercept formula. So I'm going to start with d of t, which is my y. It's going to be m, the slope, times t, my independent variable, plus b, my y-intercept, or in this case, my d of t intercept. And I'm going to start by finding the slope. So I can use any 2 points in this table to find the slope. And as we've been reminding ourselves in this section, the slope m is equal to some change in y over a change in x. Or in this situation, it's going to be delta d of t over delta t. And I can take any 2 points in my table and use them as point 1 and point 2. And I'm going to take my first 2 entries, mostly because I have some zeros in there and it makes my math a little easier. So I need to take the d of t value for the second point, which is going to be 45 miles. And I'm going to subtract the d of t value for the first point, which is 0. And now I'm going to do the same thing for time. So my t value for the second point is 1 hour, and my t value for the first point is 0. So I'm going to end up with a slope of 45 miles per hour. Now, what is that? Where have we seen that before? That's the speed that the car is traveling. So this brings up actually something pretty important. This tells us that speed is the slope of a distance versus time graph. This is going to be important, and you're going to need to file that away not only for the rest of this problem, but for future problems. So I've got my m. Now I need to find my b. So let's just update our equation here, and we have d of t is equal to 45. I'm going to put this as mph for the moment, times t plus b. And we need to remember that b is the y-intercept, or the d of t intercept. So I'm going to take my values for t equal to 0 up here and substitute them in and figure out what b is going to be. So d of 0 is 0, and I've got my 45 miles per hour, and that's going to be times 0. That's what I'm substituting in for t, plus b. So my intercept is going to be 0. And now I finally have a full expression for d of t, which is going to be that 45 miles per hour times time. And there's our answer to the first part of the problem. All right, so let's see what part B asks us. Part B asks us to graph y equals d of t. So I'm just going to rewrite what d of t is so that we can see it. So there's my slope of 45 miles per hour times t. And if I'm going to make a graph, I need axes. So let's draw some axes here. And what's going to go on the horizontal axis? That's right, that it's going to be our independent variable, which in this case is going to be time. And on the vertical axis is going to be our dependent variable, which is going to be d of t. I need to put some units, I need to put some intervals on here. So of course I'm going to start at 0, and then I'm going to look to my table where my intervals were 1 hour and 2 hours. And then my d of t values, again, started at 0, and I had 45 miles and 90 miles. And I'm just going to plot my points, and I've got 0, 0, I've got 1 hour and 45 miles, and I have 2 hours and 90 miles. And if I draw my line here, I do in fact have a straight line. It does in fact have a y-intercept of 0, which agrees with my equation. And the slope is going to be that 45 miles per hour. So there's our graph. And there's a part C. And part C says, what is the slope of the graph in B? What does it have to do with the car? Well, we've already found the slope of the graph in B, and it's that 45 miles per hour. So we know that M is 45 mph. And what does that have to do with the car? Well, we know that that is the speed of the car. And as we said earlier, speed is going to be the slope of a distance versus time graph. And that is something important that you'll need to remember for later.